Okay, so part A wants you to determine the oxidation number of Cl and NaOCl. So we know that Na has to be +1 because it's group 1, and O is most of the time 2-, so that leaves Cl to be plus. So part B asks you to calculate the number of grams to prepare 100 milliliters of 0.5 molar Na2S2O3. So you're going to start with B, which is going to be 100 milliliters. And then we know that molarity is moles per liter. So we know that 1,000 milliliters, which is 1 liter, is going to be equal to 0.5 moles of Na2S2O3. And then to get it into grams, you're going to put 1 mole Na2S2O3 over the molar mass, which is 158.1 grams. And that comes out to 7.9 grams of Na2S2O3. So for part C, they want you to find the limiting reactant of the three things they gave you in terms of H2O. So I'm going to start with Na2S2O3. So it gives you the molarity, so I'm going to set it up starting with moles per liter. So over 1 liter, and it says per 5 milliliters, so that's going to translate into 0.005 liters over 1 mole Na2S2O3. Then you want to use your mole of H2O from the equation, and there's 1 mole of H2O for every 1 mole of Na2S2O3. And by doing that, you get 0.00250 mole of H2. Okay, so I solved out the rest of them, and the only thing that I did different is I used 4 moles of NaOCl and 2 moles of NaOH because in the equation, that was how it was balanced. And I determined that NaOCl was the limiting reactant. So part D gives you a graph, and it asks you to find the temperature change. So you would just do, technically you're doing the equation, change in temperature equals final temperature minus initial temperature. So from the graph, the final temperature is 32.5 degrees Celsius, and then the starting temperature is going to be 20 degrees Celsius, and you get 12.5 degrees Celsius as your change in temperature. Okay, so part E asks you to find the heat energy for the reaction mixture. So you're just going to use the equation Q equals mc delta T, and you do 15.21 grams 3.94 joules per grams Celsius times 12.5 degrees Celsius, which is the change in temperature that you got from part D. And then once you solve that, you get 749. Okay, joules. So part F, you're going to do stoichiometry, and you're going to start with your answer from E, but it's going to be negative because the heat's released. So it's going to be negative 749 joules. And then to do that, you want to change it into kilojoules. So that's going to be 1,000 joules. And then you want to have 1 mole on top, and then put 6.25 times 10 to the -4th mole reaction, because that was the number that we found previously from your limiting reactant, that one right there. So you have to plug that in because it's your limiting reactant. So once you do the calculations, you should get -1.20 times 10 to the 3rd kilojoules per mole reaction. So part F shows you a new table where the concentration has stayed the same, but the volume has doubled. And it says that the magnitude of the enthalpy change calculated from the results of the second experiment are the same. And I want you to explain that. So because the volume is doubled, in order to have the same concentration, the moles must also be doubled. So therefore, that's going to double the amount of energy produced. And so it's going to be like 2/2, which still equals 1, because you're doubling two things that basically cancels out. So the amount of heat per mole will still remain the same. So part G wants you to write a balanced net ionic equation for the reaction initially given. So that reaction is Na2S2O3 aqueous plus 4NaOCl aqueous plus 2NaOH aqueous yields 2Na2SO4 aqueous plus 4NaCl aqueous plus H2O liquid. So from there, you want to split up all your aqueous things into ions. So you're going to do 2Na plus aqueous plus S2O3 minus 2 minus plus 4Na plus 4OCl minus plus 2Na plus 2OH minus yields 4Na plus SO4 2 minus plus 4Na plus 4Cl minus plus H2O. And then you're just going to cross out your spectator ions. So you have 2 NAs, 2 NAs, 4 NAs, 4 NA, 4 NA. And then you're just going to rewrite your equation with the remaining ions. Yields 2SO4 2 minus aqueous plus 4Cl minus plus H2O